All right, hello and welcome to Instant Insights. At Global Data Strategic Intelligence, we track over 100 tech, industry, ESG, and macro themes impacting all major sectors. I'm Patrick Mridha, and today I am joined by Romilly and Leech, who we're both analysts at Global Data Strategic Intelligence team, and we're going to be talking all about the future of industrials. We've done 4 episodes of this Future of series, which we were using to look at the next 10 years of the leisure, consumer, finance, and healthcare sectors. And the last one, perhaps sadly for all of our loyal listeners, is industrials. So we'll be looking at aerospace, defense, automotive, construction, and mining industries with this one. Glad to be back and joined with Romilly today. One of the big themes that we saw in this report was robotics. It's been seen in some of the other ones, but presumably it's also going to make a big impact in the industrial space as well.
Yeah, you'd be very safe to assume that, Patrick, actually. So I'll start with a couple of numbers for you, actually. So the industrial robotics market is going to be worth $45.1 billion by 2030. So that's going to be growing at a compound annual growth rate of 10% between 2023 and 2030. But at the moment, in the industrials space, robots are used for quality control, automated assembly lines, and welding and cutting. But I'm sure that you want to hear about what is going to happen in the next few years.
Obviously.
Of course. Mainly, robotics will improve productivity in the industrial sector as part of what we call Industry 4.0 technologies. So these are technologies that enable intelligent automation and disrupt the supply chain. They'll be deployed in environments that might be hazardous to human health and safety. So these are areas with things like repetitive or strenuous lifting, dusty, hot or cold conditions, and painting booths where fumes can harm human health. They'll also be integrating with AI to make real-time decisions and adapt to environments. So this would be for robots that are, for example, pickers in warehouses and fulfillment centres. And lastly, humanoid robots will be used for tasks requiring high flexibility and adaptability. And collaborative robots or cobots will work alongside humans on specific tasks.
So where in particular might we see ourselves working alongside humanoid robots then?
So this would be things like car manufacturing. This year in March, actually, Mercedes-Benz introduced a humanoid robot which goes by the name of Apollo. Apollo uses sensors and AI capabilities to perform complex tasks with precision. Its humanoid form means it can operate in spaces designed for human workers. So this makes it really adaptable to existing workflows and reduces production time by automating these repetitive and labour-intensive tasks. And it also minimises human error.
Presumably there must also be some challenges in implementing robotics as well, right?
Well, certainly. You've probably already guessed, but as is generally true with new technologies, the costs are really high, and companies will have to invest some hefty sums if they want to add robots to their operations. It's probably also complex and time-consuming to try and integrate new robotics with their already established technologies. So companies would really have to weigh up whether this is actually worth the time and investment. Alongside this, of course, there'll be regular maintenance and repair costs to ensure robots continue to operate efficiently. And companies will also need to either retrain current employees or hire new ones, given that there'll be kind of specialist skills to do this. It's definitely a big investment for companies. But Patrick, I know that you have some knowledge of autonomous vehicles. Could you perhaps take over and expand on how they'll impact the industrial sector?
So I'll quickly explain what AVs are. When we talk about autonomous vehicles, we generally think of them in terms of 5 different levels of autonomy. And they all of them exist somewhere on a scale. Level 5 is what we'd consider like truly autonomous, so they can drive themselves in all circumstances. And this spreads all the way down to level 0, which is simply no onboard computer, nothing, and it's all about the driver input. For the industrial sectors, the most relevant AVs will be level 4. So when that technology starts to really mature, that's when it will be most useful in the industrial sectors, and these are vehicles that can drive themselves within set parameters. They generally don't need human intervention, but they're not entirely responsible for themselves and how they move. These kinds of vehicles are ones that can be used in warehouses, distribution centers. Tasks like moving goods, organizing inventory, things like that. This, much like the use of robotics in warehouses, reduces the need for manual labor, and their use for transportation and logistics means that we can incorporate self-driving trucks in the longer term future, which will be equipped with sensors and data analytics, which will be useful for inventory management and generally tracking where these things are, and how they're performing. Predictive maintenance will be a big one as well. Tie that in with AI, and it'll really help improve industrial workflows. And with AI, obviously, we can't ever really have a future of conversation without talking about AI. So before we go, Romilly, would you mind giving us some of the information about how AI is expected to impact industrials?
Yeah, so the global AI market is going to be worth $1 trillion by 2030. Currently in the industrials industry, AI is already helping facilitate things like planning, design, modelling, safety, site monitoring and maintenance, and also emissions tracking. It also enhances the development and implementation of other technologies, so things like robotics, which we've previously mentioned, and IoT. But in the future, we'll be looking at AI being used for things like quality control and predictive maintenance. So this means automated product inspection and identification of abnormalities. So for example, we might be looking at something like a jet engine, and AI can commission repairs before it even starts having problems or starts breaking. AI can also optimize the supply chain, so that includes inventory management, demand forecasting, and logistics. So just like those algorithms can predict maintenance problems, they can also predict market demands and adjust production and pricing accordingly. So for example, the company Eneos launched an AI system in May 2024, so that's this year, and this automated atmospheric distillation units at its Kawasaki refinery, which creates petroleum and petrochemical products. So as you can imagine, that's quite a complex process, but the AI system can automate it.
Okay, and with that, thanks for joining me today, Romilly. I'm glad to be back doing some things for Instant Insights. For everybody, thank you for listening. And from us in Strategic Intelligence, see you next time.